The next thing I want to talk about is homogeneous equation systems. A homogeneous equation system fits into this form. AX equals 0, where that 0 is the null vector. Okay, so if A is a n by n, x is an n by 1, then this 0 here is the n by 1 null vector. Okay. Whenever you have a homogeneous equation system of this type, you know there's always going to be a trivial solution. And the trivial solution is just this. x1 star equals x2 star equals dot, 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 equals xn star equals 0. You know that'll work. Because if all the x's are 0, this is a linear equation system, all the x's are 0, then that has to solve the equation system. And this is called the trivial solution. Okay. For example, let me just make this a little more concrete for you. Suppose we have two equations, x1 plus x2 equals 0, and x1 minus x2 equals 0. Well, it's obvious if x1 is 0 and x2 is 0, it's obvious that that equation will be satisfied. Because you'll have a 0 here. 0 plus 0 equals 0, right? 0 minus 0 equals 0, right? So this is an example of a 2 by 2 homogeneous equation system. And whenever you have a homogeneous equation with all zeros on the right-hand side for your D vector, the trivial solution is always going to work. The question arises, however, are there any other solutions? Okay. Is this trivial solution the unique solution? And actually, you know how to answer this already, don't you? Under what circumstances will the trivial solution be the unique solution to this equation system, the only solution? Ben? Right. If A is non-singular, and Ben, what's the simple test whether or not A is a non-singular? Yeah, the determinant. And what about the determinant? Yeah, as long as the determinant of A is not 0, then A is non-singular, and a unique solution exists to the equation AX equals 0. Okay. So, if the determinant of A does not equal 0, that implies that a unique solution exists to this equation system. Okay. And since we know the trivial solution always works, then it has to be the unique solution. Okay. But what happens if this is true? Now, it wouldn't be true for this case, but for a different case, suppose the determinant of A is 0. Okay. What would that mean now? That A is what? Matrix A is said to be what? Singular. And Right. And a unique solution does not exist, but that could mean one of two things. Either there's no solution or an infinite number of solutions. And in this case, we know a solution exists, the trivial solution. Therefore, it means there's an infinite number of solutions. Okay. So if you have a homogeneous equation system and you find the determinant of A is 0, that implies an infinite number of solutions. See, in this determinant test, let's go back over this. This determinant test says the following. If you have an equation system like this, AX equals D now, where D is not necessarily 0. Could be 0, but it doesn't have to be. Then if the determinant of A equals 0, that implies, and actually is equivalent to, this, that a unique solution to AX equals D does not exist. Okay. And that could mean one of two things for the general case. It could mean there's no solution at all. The equations are inconsistent. They're incompatible. So there's no solution. Or it could mean that there's an infinite number of solutions. But for the homogeneous case, for this case right here, we know there's always a solution. The trivial solution always works. So this statement's still true. If the determinant of A was 0, it means a unique solution does not exist. But really what that means is that there's an infinite number of solutions.